Hello, everyone. For those that may be interested in a little behind the scenes look at the architecture for TacarEZ, this is kind of a diagram of what's going on. I'm in Miro right now. This is actually the tool that we use as a team to coordinate our work and our planning and everything like that. The link for this is in our DevPost, and it is a public link, so feel free to check it out and look at our notes and how we got to where we got to with our application. The actual TacarEZ website is an Angular application. We're using PrimeNG component to do that, and as well as the ArcGIS JavaScript API. And so this is what we use for the mapping. The components are PrimeNG, and it is built in Angular. And so that Angular code is built and is hosted in an Azure static website. We also are using Cosmos DB for our database. This was our first time using Cosmos DB. We were initially thinking of doing a SQL database, but because of all of the unstructured data, we figured that the Cosmos DB would be the best fit. We are using Azure Active Directory, the B2C, for our account creation and authentication. So when you do log in, you're actually seeing you're being redirected to Azure Active Directory, and that just really helps us with all the password stuff and resetting and everything like that. Behind the scenes, the API is being coordinated. So we've got multiple APIs. We've got our main API here, TacarEZ API, and what this does is it communicates with two of these other backend APIs. One that talks to GitHub. If you look at our project overview, behind the scenes, the map data is actually stored in GitHub, and I'll show you that here in a little bit. The the signing and everything like that happens in DocuSign. And what we want to do is separate it so that this takes care of that authentication piece for DocuSign and does all those DocuSign processes. It can be deployed separately. This one does the same thing, but with GitHub. So all the authentication and stuff like that happens over here. And so our TacarEZ API, which has access to the database and can write to the database and can also interact with these other services to push things to GitHub or request envelopes. This is what it looks like in Azure. So you can see we've got multiple storage accounts that are associated with the app service plans that are associated with all of our function apps. So function apps is Azure's serverless offering for function as a service. So we've got multiple function apps. We've got application insights, which is just logging to help us with any troubleshooting. We also have an email API that's being actually built because it's really easy to integrate with a Logic app to send notifications. This is what's being used to send out those notifications once a signature is complete. And we've also got what's not represented over here. It was a later addition. Is this webhook here? And so what a webhook is essentially it's waiting for data from DocuSign. So anytime something happens from DocuSign, whether that's a recipient signs something, a recipient opens an envelope, an envelope is sent, that actually, and I'll just represent it over here, is sending data to our webhook over here. And that webhook, what it does is this is actually connected to our database too. So I'll just make this change over here and just represent that over here. So this is our webhook. Once an event happens in DocuSign, it posts to our function app that listens for that, and then it logs it to, oops, that's not our database here. I'll just open up our database to give you a look at kind of how it's structured. So this is Cosmos DB, a NoSQL database, pretty much just similar to MongoDB, just Azure's version of it. If I look up over here, what I'm doing is this is logging all of the DocuSign webhook. So if I open up this, what I have it doing is when those webhooks come in, it'll store it by the envelope ID, and then any kind of events get pushed to this events history here. So you can see as these messages come in, they get logged into this database here. What it also does is it adds, it's monitoring it, and what it'll do is if it's something listed like complete, then it'll write to our other database over here. And so this database, this features database, is what holds all the metadata associated with the maps. So if I look at this feature over here, you can see what it does is it'll populate the envelope status here with the recipient's information, that email, the initial date it's sent, delivery date, and the sign date. Did want to also highlight, as I mentioned, behind the scenes, what's actually happening with the map data is we're not actually storing that in our database. In hindsight, that might be something that we want to consider. Working with GitHub it does provide a lot of values. So let me just go to that chimpanzee map that we did over here. What's great about this is with GitHub, you can click on the item and they actually render the map for you. So this was that merged in portion of the map over here. And what's cool is I can get that raw data. So this is that raw GeoJSON data. This is that data that was hashed and provided in the document or the envelope. But what is really a great feature of storing this in GitHub is we have this history over here. And so I can go back and look at the older version of the map by clicking browse over here. And so this is that older version of the map. And so as the map continues to evolve, we can, with GitHub, we can go back and get multiple previous versions. And that's something for a future release that would be great, is the ability to go back in here and look at the different versions. What we also are capturing but aren't displaying are the notes for the changes, and so it would also be good to be able to display those notes for people to see. So that's just quick behind the scenes. If you have any questions, feel free to reach out to us. We'd be happy to help in any way we can.